Hello everyone. This question has been taken from Irodov Fundamental Equation of Dynamics question number 72. The question is find the acceleration W of the body 2 in the arrangement shown in figure 1.15. If its mass is n times as great as that of mass of bar 1 and the angle that the inclined plane forms with the horizontal is equal to alpha, the masses of the pulleys and the threads as well as the frictions are assumed to be negligible. Look into possible cases. The saying mass of the threads negligible, mass of the pulley negligible, there is no friction in the pulley, there is no friction on the inclined plane. So let us solve this problem. So figure 1.15 we brought here and we showed all the forces acting on the mass 1 and mass 2 and on the pulley. Since the mass of the thread is negligible and there is no friction in the pulley, so this section of thread will be having the same tension throughout that we have notated by T1. This section of the thread which is passing across the pulley B will be having the same tension throughout that we have notated by T2. Weight of the body 2 is acting downwards, that is M2G. We have assumed that this is moving downward with an acceleration W. And W1 is the acceleration of mass 1 up along the inclined plane. Now to establish the relationship between W1 and W, we can think of this mass moved a distance d up along the inclined plane. So it means B will fall down by a distance d. The pulley B will fall down by a distance d. It means this section of the thread will be slackened by d and this section of the thread will be slackened by d. But this thread is attached to body 2 at one end. So this thread will all the time be under tension. It means the body 2 will come down by 2d distance to keep the thread tight. So it means, so what does it signify? That acceleration W will be 2 times the acceleration of W1. So here we got equation 1. You can go through the write-up. This will be easy. This will give you ease in understanding. So equation 1 we got. Now we make the free body diagram of body 2. So in body 2 which all forces are acting we have shown here. M2G is the weight, M2G. T2 is the tension force exerted by thread on the mass 2 in the upward direction, and W is the acceleration in the downward direction. So we can write the equation from Newton's law of motion. M2G minus T2 is equal to M2 into W. So this is equation 2. Same way we will make the free body diagram of pulley B. On pulley B which all forces are acting? From this end tension of the thread will be acting downwards on the pulley, and this end also tension of the thread will be acting downward on the pulley. So this tension in this section of the thread is T2. So T2 plus T2 will be acting downwards. And T1 is the force exerted by this section of the thread on the pulley B in the vertically upward direction. Since mass of the block B, mass of the pulley B is negligible, so there is no gravitational force acting on it. So we can apply Newton's law of motion on it, and we can write 2 into T2 minus T1 is equal to mass of the pulley B into W1. Actually, it should be W1 because pulley B will come down with the same acceleration as mass 1 will be moving in this direction, because both of these two entities are attached to the same thread. So please do a correction. You can write W1 here instead of W. Now mass of the pulley B is 0. So we can, so our equation will become this: 2 into T2 is equal to T1. We will make free body diagram of mass M1. On M1 along the plane, along the inclined plane, M1G sine alpha is the component of the gravitational force acting. T1 is exerted by the thread on mass 1 up along the inclined plane. W1 is the acceleration. So from Newton's law of motion, we can write this equation: T1 minus M1G sine alpha is equal to M1 into W1. We will replace W1 by W by 2 from equation 1. Then again in the next step, we will replace T1 by T2. So this is 2 into T2 minus M1G sine alpha. So this we can achieve from equation 3. So we will keep on solving this. We reach to this stage. We will divide each term by M1. So M2 by M1. So, and 2 by M1 we can replace by N. And finally, upon solving, we will get the numerical value like this. If you notice this expression on the right side will always be positive. It means the direction of W which we selected is the downward only along the along the direction of the gravitational acceleration. Okay. So in the vectorial form, we can write it W vector 2 into G. G is downwards to 2n minus sine alpha. So this is your answer. I hope the concept of solving this is clear to you. In case any doubt, please write. These all expressions are nothing, so you can do by yourself. So you can do the calculation by yourself. Thank you.